So we're going to start section 1 of chapter 7 for pre-calc. And we're just going to solidify the idea of exponents and solving exponential functions, which is typically taught in Algebra 2, but I just want to confirm. And the very first rule that we're going to establish is with the same base and we're multiplying. I usually teach this as if I had like a squared times a to the third power, just to change it up. Because what this means is it's repeated multiplication. So there's 2 a's here, there's 3 a's here. I should put dots in there. So that means we have a total of 5 a's, which is basically what operation between these two exponents is addition. So when you see a problem like this, what they're trying to get you to realize is if you have the same base with multiplication, that means that we can add the exponents. Which is why in an earlier unit we talked about combining like terms. So this would simplify to, well, I'd rather do 2x minus 4x first. Negative 2x and negative 3 plus 5 would be plus 2. And I'd be fine if you just left your answer like this. We can get into an argument on where you can, how far you want to go. And I mean, I already looked at the answer key. You know me. Sometimes what they'll do is factor out a negative and then do the reciprocal, which is something we'll talk about later anyway. So anyway, I don't need you to do all of this fancy work. What I'm looking for is that you understand that you're adding the exponent. But it is important when we get to negatives that you know exactly what's happening. So here's another problem where we have the same base, but this time we're dividing. And if you looked at the previous one, you may have reminded yourself that you subtract the exponents. Maybe I should change colors just to kind of give you a different scenario. If you had like a to the 5th divided by a squared, you might rewrite that as, I should have given myself more room, 5 a's on top, 2 a's on bottom. Well, 2 of the a's would cancel. We've learned that. So you're left with a cubed. And how do we get a cubed? Well, 5 minus 2 is 3. So that's your rule. So if we were doing this problem, notice that we still have multiplication on top. So in the numerator, I would do this first, where you need to add your exponents together. Notice that I'm combining like terms just like I did in the first exercise. So it's 2 to the 4x plus 4. And in the denominator, it's going to be 2 to the 3x minus 4. Again, I'm multiplication right here, so we're adding the exponents. And I'm combining like terms, 1 minus 5, or 1 plus negative 5, if that helps anybody. So then what we can do is divide our, we can subtract our exponents because of the division. Now notice that I'm putting parentheses around all of this. Why? Because you need to distribute that minus into the problem. So 4x minus 3x is really 1x, and 4 minus negative 4 is really 4 plus 4. So we're looking at x plus 8. There we go. Now the next problem, you probably remember from Algebra 2, you may have even learned this in Algebra 1, is a power to a power. You multiply the exponents. Sometimes I explain this by saying, well, what if we did a squared cubed? Okay, well, that's the same thing as a squared times a squared times a squared. Well, there's 6 a's right there. Well, how do you get from 2 and 3 to get to 6? That's through multiplication. So notice that we're just adding a few rules to this. So we're multiplying these exponents, a power to a power. But notice that I put x minus 2 in parentheses. And sometimes I use the phrase distribute. I don't know if I really should because it's not really the distributive property. But we're looking at 2 to the 3x minus 6. And then times 2 to the 2 minus 2x. Well, what did we learn earlier? I'll switch back to red. When we're multiplying with the same base, we need to add our exponents. So we're looking at 2. 3x plus negative 2x would be 1x. Negative 6 plus 2 will give me negative 4. So again, this isn't the only way to do the problem. I have no problem showing you the answer keys. but sometimes the answer keys lack an explanation. So it's definitely worthwhile to watch the video. I could obviously share the answer keys with you, but that might not help you understand. So as I move on to the next one, I mentioned earlier about negative exponents. I think it is important to mention that your base cannot be 0 for a negative exponent. And I should mention it down here as well. A cannot equal 0. But the moral of a negative exponent is it's the same thing as doing the reciprocal. And some people write it this way. I actually prefer to write it this way. But some people also write it as 1 over a to the nth power. So either one of those is good. So as we look at this problem, what you might do is think about, oh, well, I see a negative right here, but I don't really know how it pertains to this problem. Is what you're really doing is factoring out a negative. And I hope you agree that this is correct, because if I distribute the negative in there, I do get negative 2x plus 2. So now that my exponent is negative, I would rather write it this way, 1 over 3 to the 2x minus 2 power. So I'm going to stop right there, but I just showed you the answer key where he wrote it as 1/3 to the 2x minus 2 power. I just don't have that preference. If you see a problem like this on a multiple choice, be ready for this to be the correct answer and not what I wrote down, but they are both equivalent. So again, the base cannot be 0 when you do this problem, because if the base is 0, our calculator blows up. You can try that out if you want to try 0 to the 0 power. But for all other bases, this will always equal 1. Okay, and I could go on a long spiel as to why this is the case. You probably don't care that much, or if you do care, bring the question to class or email me and say, hey, I cared about that. But if you notice in this problem, the bases are not the same. So we have to fix that. And let's change colors again. So what I need to do first, I don't think I've had any other problems like that yet. Bases are all the same. Yep. Is I'm going to change 4 to be 2 squared. I hope you agree that 4 is the same as 2 squared. Why did I choose 2? Because the other two bases are 2. So now I have this power that I need to take to that 2x plus 2 power. Okay, this is still here. Then times 2 to the x minus 1 all over 2 to the 5x plus 3. So as I do a power to a power, this is really 2 to the 4x plus 4. See how I have to multiply? Times 2 to the x minus 1 all over 2 to the 5x plus 3. Well, now that I'm multiplying right here with the same base, I add my exponents. So I'm looking at 2, 4x plus 1x is 5x. 4 plus negative 1 is 3. All over 2 to the 5x plus 3. Well, now we're dividing, so I need to subtract my exponents. 5x plus 3 minus, notice it's the quantity of 5x plus 3. So as I distribute that in there, I get 2 to the 0 power. 5x minus 5x is 0. 3 minus 3 is 0. But that's equal to 1. And kind of like what I said earlier, is I could speak all day about this, but I hope you would agree that it must equal something that's like 1, because if we have something divided by itself, like right here, those two things should cancel out, and you're left with 1. So it's certainly not equal to 0. If you follow our rules of exponents, it's got to equal something that's not 0, and that something's 1. And then just one more rule that you probably learned in Algebra 2, but we're solidifying here in pre-calc, is if you see a problem like this, I don't know if it shows up on your paper, it says a to the m over n. It's the same thing as the nth root of a to the m power. You might also see on Google it written this way, the nth root of a and then to the mth power. Now what I would do is wait until the very end to do a problem like this. because we had the same issue as from the previous problem, that we need the same basis. So before messing with that square root, now you could mess with the square root right away, I just wouldn't. I would rewrite 9 as 3 squared. And hopefully you agree that 3 squared is 9. If not, we have other issues that we need to talk about. Let me put equals in here. So then that's equal to, again, I'm just rewriting the first one because I don't want to mess with that yet. A power to a power, we have to multiply. That's 2x minus 8. And now when we're multiplying with the same base, we can add our exponents. So the square root is still there for right now. 2x plus 2x is 4x. 2 plus negative 8 is negative 6. And now let's mess with that square root. So the premise is, and I need you to really understand this, is that this problem is now the same as everything to the 1/2 power. Why? The square root has an implied 2 as the index. And now we're back to a power rule, which means we need to multiply. And I hesitate to use the word distribute, but that's really what we have to do, is distribute that 1/2 in there. So half of 4x is 2x, and half of negative 6 is negative 3. And that's the answer we're looking for on number 6 here. So feel free to pause the video, copy down anything you need to, or go back and rewatch it. There's nothing wrong with that, because the next page is just filled with practice problems of getting you to do this. And how about you hit pause in the video and you work through some of these, because now it's just a combination. It's just like a hodgepodge of a bunch of questions. And maybe what I'll do is just jump to the answer key here shortly. But I do want to do at least one of these, maybe even a couple of them. Because every year I do this, somebody does this wrong, where this is really 3 to the first power. So as we take each power to that power, the problem looks like this: 3 to the 1 times 3. A power to a power, you multiply the exponents. Notice that it's the exponents that are multiplied. Then times x to the 3 times 3. And then times y to the 5 times 3. So I would like you to simplify that this is 3 to the 3rd power, but I want you to write down that it's 27, x to the 9th, y to the 15th. If you're confused why this is 27, it's 3 to the 3rd power. That's 3 times 3 times 3, which is 27. Same thing with the next one. Again, notice that I'm doing the power to a power first. That's just how I prefer doing the problem. You don't have to do it my way. But 2 to the 3rd power is 8. Becomes a to the 6th, b to the 9th. Again, I'm multiplying those exponents. And then when I multiply, the coefficients are multiplied together. So this is 24, and I add my exponents. A to the 1st, a to the 6th, that's a to the 7th. 2 plus 9, 11. Oops. So maybe just jumping ahead to the next one, you probably remember from Algebra 2 that you subtract your exponents. You may also remember a rule where the exponent's larger is where the answer ends up. So a to the 5th, 5 is larger than 3. So because 5 is in the denominator, a is going to end up in the denominator. And 5 minus 3 is 2. Now you must, I guess I should say, simplify top and bottom, because they're both divisible by 3. 12 divided by 3 is 4, and 15 divided by 3 is 5. Now, if you do this problem differently, you might do 3 minus 5 and get a to the negative 2nd power. But here's the thing, is we never leave our answer with a negative exponent. So how do we fix the negative exponent? We move it to the denominator and make it positive. So again, hit pause in the video. I'm going to jump to the answer key and just kind of show you a few answers. Again, at any point, hit pause in the video, and then I'll see you in a second video to finish up. I'll start down here in a second video.